YouTube channel. In this lecture, we will solve questions of VOR chapter from Keith Williams. We are going to solve questions starting from question 1 to 121 up to question 129, the last part. So let's begin. Question 121. On an RMI, the front end of the VOR pointer indicates what? So this is your RMI indicator. On this RMI, you get two pieces of information: magnetic heading. Then there are two arrows. One arrow will be pointing towards the VOR station. Another arrow will be pointing towards the NDB station. So for this arrow, the head of this arrow will be giving you QDM or track to the VOR, and the second arrow, the head of it will be giving you QDM to the NDB. And similarly, the tails will be pointing at the radials. So for VOR, this tail will tell you the QDR or the radial you are situated on, and in case of NDB, the tail of that needle will be telling you QDR, that is tracked away from the NDB station. So the front end of the VOR pointer, that means the arrow head, will be showing you the track towards the station. So correct answer is radial is wrong, that is indicated by the tail. Magnetic heading from the station, so again that is wrong. Radial magnetic bearing from the station, so the magnetic bearing from the station is nothing but your radial or QDR, so this is also wrong. So the correct option will be option Charlie, radial plus 180. Radial is QDR, and when you add 180 to QDR you get QDM, and that is what is indicated by the head of the VOR pointer. So option C will be the correct answer. Question 122. Which of the following statements about scalloping or path deflection of VOR radials in relation to the accuracy of nav system is correct? Scalloping has a negative effect on the accuracy of navigation. It has a positive effect. It has no effect because the accuracy is independent of VOR or DME measurements. Scalloping has no effect on the accuracy of navigation because it only results in the movement of the needle of the CDI. So the correct answer is scalloping has a negative effect on the accuracy of navigation. What is scalloping? It is nothing but the deflection, bending of VOR radials. So if VOR radials bend or get deflected, the radial that you will be receiving, the aircraft receiver receives, will be an erroneous or a wrong radial. Okay, and you will be following, hence you will be following a wrong track. So that is negative. So therefore, scalloping is a drawback or a disadvantage that you get. So answer is option A. Question 123. Terminal VOR is what? It is a test VOR, that is wrong. High power VOR used in the terminal area. VOR with a limited range in the terminal area. Low power VOR with a limited range in the terminal area. So the correct answer for this should be Charlie. VOR with a limited range used in the terminal area. So yeah, so it is Charlie. VOR with a limited range. So this VOR will only serve aircraft in the terminal airspace of an airport. Next, along with this, there are other VORs like broadcast VOR. On this VOR, you will be broadcasted information relating to weather and airfield. There is a Doppler VOR, okay, which is a next generation VOR, okay, better than conventional VOR, but works just the same. And then we have terminal VOR, which is there to serve traffic in the terminal area. And then the last one is a test VOR, the testing VOR. We use this VOR to test the VOR receiver in our aircraft. Okay, if they are indicating accurate bearings, to and from indications or not. Let's go to next question. Question 124. Aircraft is flying on a heading of 245 towards a VOR at flight level 300. The HSI displays a selected course of 255. Two indication. The variation at both places are given to you. Deviation is given when the pilot keeps the CDI on the left inner dot on a display with two dots on the either side. Let's draw this. Now aircraft is flying on a heading of 245. But first let me check if this heading is true or magnetic. And course is 255 with a 2 indication. That means, so first address that 255. That means the reciprocal of it is 075. So aircraft is on radial 075 and its heading is the heading of aircraft is 245. So I'll just check it. 124. Aircraft is on a heading of 245. So it's just given heading. It's not stated whether it's true or magnetic. The HSI displays a course. So now HSI displays a course of 255. Now in horizontal situation indicator, whatever heading you will be displayed will be magnetic only. So let's consider this is so magnetic heading 245. So let's draw that. So aircraft is on a heading of 45, right? On a heading of 245. Now CDI. The CDI indication is left, one dot left. So let's draw the CDI here. Now on the CDI, you will put the OBS selection. So now the what you will put is 255 in the CDI. So as to get a 2 indication, right? You want to track towards the VOR and you want to go on what? You want to go on to radial 255 and you are on radial 075. You want to go to radial 255. So you have put 255 in order to get a 2 indication. Now if you are correctly on the center line of this radial, the CDI should remain in the center. Now, but in the question it's given that CDI has deflected to the left hand side. Okay, so that means one dot left. So that means CDI, there are two dots. CDI is to the left hand side. Over here is 255 and the indication is 2. Now one dot is equal to 5 degree. So if CDI has gone or has deflected 5 degree to the left hand side, that means it is telling pilot to fly left. Now it will tell pilot to fly left when the pilot has deviated from his track to the right hand side. Now going inbound, this is your right hand side and this is your left hand side. So that means pilot has deviated to the right of the track. So that means pilot is somewhere here and the radial passing through this position will be less than radial 075 because it is to the left of it. So it will be radial 070. So that means pilot is situated on radial 070 and flying inbound. Okay, it should be on radial 075, but currently it is on radial 070 and therefore it is getting a left hand deflection. It is getting a left hand CDI deflection telling the pilot to turn left so as to intercept the correct track towards the station and go on to radial 255. So of all the options listed here, the correct one will be VOR will be approached along the radial 070, VOR will be approached 080, aircraft will go from the south of VOR, aircraft will pass north of VOR. So correct option is option alpha. Aircraft will approach the VOR station, okay, on radial On radial, what radial? 070. So question 124, the answer is option A. Okay, 070. Okay, so you are on radial 070, so you will be flying inbound towards VOR on that radial if you do not make a correction. Let's go to the next question. Question number 125. Simple aircraft is at 52 degree, 52 aircraft is at 52 degree 9 minutes, okay, north, and VOR is at 54 degree 42 minutes north. That means VOR is to the north of aircraft. So your aircraft VOR is here and your aircraft is to the south of it at a lower latitude, at a lower latitude. Let me verify this if it's north or south. So it may be a printing error, so I apologize. Take your extra time. 125. Okay, it is south. So it is the south hemisphere. So if in the you are in the south hemisphere, 52 degree north, 52 degree south will be here, and 54 degree south will be here. Okay, so aircraft is at 52 degrees south. So I'm drawing your aircraft here, and VOR is at 54 degrees south. Which aircraft is directly to the north of VOR. Aircraft is to the north of VOR. So aircraft is on radial 360. True. Make it magnetic because all radials are magnetic in direction. Apply variation at VOR. Variation at VOR station is 14 degree east. So with a variation of 14 east, the radial will be 360 minus 14. Variation is magnetic is least, which is equal to 346. So aircraft is situated on radial 346. Okay. Now, in order to read the most accurate ground speed by the DME receiver, the pilot must follow which radial of VOR. Now, you will get accurate ground speed whenever aircraft is flying towards the DME station directly or flying away from the DME station. If you are flying from any other direction, the ground speed given to you will be wrong. Now, when you are flying towards the DME station, you will get distance information from the DME. You will get time that it takes for the radio pulse to go from your aircraft to the ground DME station and come back. Now, with distance and time known to you, you can easily calculate ground speed. So this is how speed is calculated with the DME equipment. Okay, and it will be accurate when aircraft is flying directly towards the station or away from the station. If you are flying laterally like this somewhere here, the ground speed will be 0. Okay, and so the most accurate will be when you are flying directly or away from it. So now in this case, VOR and DME are co-located. So aircraft should be flying directly towards that station or away from that station. So it should be flying on radial 346 magnetic inbound or radial reciprocal of 346, whatever that is. So you have to fly that outbound. So the correct option here is 346 radial, or reciprocal of 346 is 166. So you have two options: follow 346 radial inbound, overfly the VOR, and then fly radial 166 outbound. So 166 is also given here. So, but your aircraft is currently to the north of the VOR, right? So to the north of the VOR, first it has to come towards the VOR in order to get a correct ground speed. So the first procedure will be to fly radial 346 inbound. So the correct option will be 346. Answer will be 346. So I'll just check it. Yeah, so it is alpha 346. Let's go to question 126. Aircraft is on a heading of 010 and the magnetic variation at the VOR is 10° west, at aircraft is 12° west. Which RMI shows the correct indication? So RMI should show first a heading of 010. So question number 126. So the RMI should show a heading of 010 for sure. Now over here you can see that HSI is 010 heading. So in all the RMI displays you get to see a heading of 010. Next thing, the course. Now the course selected here is a course of 060 with a from indication. With a from indication. That means you are following a track of 060 outbound. Okay, in that case, if you are correctly following that track outbound, the head of the needle should be pointing at 240. The tail, which is the radial, should be pointing at 060. But in this case, the CDI needle has deflected one dot to the left hand side. One dot to the left hand side. So let's draw this. So you're supposed to fly this 060 outbound correctly. If the CDI needle is telling you to fly left hand side, one dot to the left hand side, that means you have deviated from the track to the right hand side. Now going outbound, this becomes your right hand side, this becomes your left hand side. So aircraft, instead of being established on the center line of this radial, is somewhere to the right of it, let's say somewhere here, and the radial passing through this position will be what? A radial more than 060, radial 065, because the needle has deflected one dot and one dot is equal to 5 degrees. Okay, so the RMI indications will be what? The current RMI indications will be from this position. The track away from the VOR station is what? 065. So tail should be 065. The head should be reciprocal of 065, which is 245. So let's find a diagram which has these two values. So the head should be 245. So option Charlie is the correct answer. The head is pointing at 245. So the correct option will be figure Charlie, and figure Charlie is option number A. So look at the options also and look at the figure number also. Okay. If you just if you know the figure C is the correct answer, and in haste or in hurry in exam you just randomly mark option C thinking it to be figure C, that will be wrong. So figure C, option A. Okay. So this is how you do it. Let's go to question 127. You're flying along an airway which is 10 nautical mile wide, 5 miles either side, and you are 100 nautical miles away from the VOR station. If you are on the boundary, how many dots deviation will the VOR needle show if one dot represents 2 degree? If one dot represents 2 degree. So let's draw this. This is your VOR station. You are away from the VOR station by a distance of 100 miles, and the track is 5 miles stretched out. So now you should be here, correctly established here on the center line of the radial. but you have deviated from the track, and now you have found yourself deviated to the right hand side, let's say over here. Okay, so now you have to find by what angle you have deviated, this track error angle, and you have to convert that angle into corresponding dots, because on your CDI you will be getting information in the form of dots, not angle. So let's first find angle. Tan theta is equal to 5 divided by 100. So tan theta will be equal to 0.05. So theta angle will be tan inverse 0.05, which will be equal to what? Shift tan 0.05, 2.8, approximately 3 degrees. A theta of approximately 3 degrees. Now it's given here 1 dot is equal to 2 degrees. So how many dots will be 3 degrees? It will be 1.5 dot. So on your CDI indication, the needle will move 1.5 dot to the left hand side if you have deviated to the right of the track. So the correct answer will be delta, 1.5 dot. Let's go to question 128. Which statement is true about the use of Doppler VOR? The Doppler effect is used. Wrong. Doppler VOR is just like a conventional VOR, but it has one advantage, that the site error, which is a characteristic of a conventional VOR, Doppler VOR doesn't have that site error. Okay, so the Doppler effect is used to create a signal. Wrong. By using Doppler effect, it is possible to determine aircraft approach speed to the VOR. Let's read option A. The Doppler effect is used to create a signal which is received by aircraft VOR receiver as a frequency modulated signal. The Doppler effect is used to create a signal which is received by VOR receiver as amplitude modulated. So that is wrong. By using Doppler effect, it is possible to determine aircraft's approach speed. Wrong. By using Doppler effect, it is possible to determine range. That is also wrong. Correct option is option A. In case of conventional VOR, we have a reference signal which is frequency modulated, and we have a variable signal which is amplitude modulated. In case of Doppler VOR, you have the reference signal which is amplitude modulated opposite, and variable signal which is frequency modulated. So reference signal is going to remain stationary in magnetic north direction. Aircraft is going to receive variable signal which is rotating about the VOR, around the VOR. Therefore, the aircraft receiver will receive the signal which is frequency modulated in case of Doppler VOR. In case of conventional VOR, the aircraft receiver will receive a signal which is amplitude modulated. Let's go to question 129. The last question, very simple. VOR system is limited to 1 degree accuracy. 1 degree at 200 miles equals to how much? So let's draw this. This is your 1 degree. The distance from the VOR is 200 nautical miles. And we have to find out this width. Okay. So this width is equal to how much? Tan of 1 degree is equal to width divided by 200. So x is equal to tan of 1 into 200, which is equal to 3.49, approximately 3.5 nautical miles. Okay, so the correct option is option delta. So this is how you do all the sums from question 121 to question 129. Simple, easy to understand. It takes practice and proper theoretical understanding. And so I have designed my lectures and explained everything in such a manner that you get to know how to solve the sum, and also you get to know the explanation, the concept also. Okay. If you have any doubts or questions from this related to VOR or any other chapter, let me know in the comment box. I will resolve them. I also request you all to subscribe to this channel and share this video with all your friends. Hit the like button if you have liked this lecture. I'll see you in the next video. Be safe and